to Discovering Geometry with Mrs. Berry. This is Lesson 60. Today we will talk about the distance and coordinate geometry. We're going to look at the distance formula, or is it the Pythagorean theorem? Distance on a coordinate grid system is just the Pythagorean theorem. Think of a grid of streets. All of them are parallel or perpendicular lines. To go from First Street and First Avenue to 4th Street and 5th Avenue, you would travel 3 blocks east and 4 blocks north. What is the distance as the crow flies, this dotted line here? Well, it would be the hypotenuse of this right triangle. We already know that the legs are 3 and 4, so what is the hypotenuse? If you remember some special triangles, 3, 4, 5 is one of those Pythagorean triples. So it's 5 blocks if you went as the crow flies. We're going to do an investigation to find the distance formula. First, from each graph, calculate the distance of the segment by using the Pythagorean theorem. Here's our first one. If I were to draw my triangle in, I have 2 on this one and 6 down here. So 2 squared plus 6 squared equals my hypotenuse squared. 4 plus 36, 40 is what my hypotenuse squared is. So if I take the square root, and I have my hypotenuse is the square root of 40. If I get that on a calculator, I can estimate that that is about 6.3. Notice I use this almost equal sign, but I make them a little curly. That means that I'm approximating my answer. It's approximately 6.3. Look at this next one. If I fill in my triangle, I have 6 and 1, 2, 3, 4, 5, 6, 7, 8. I have 6 squared plus 8 squared equals my hypotenuse squared. What is 36 plus 64? That's 100. I take the square root of 100, what do I get? H is equal to 10. Nice even number. And our last one is 2 by 8. 2 squared plus 8 squared is equal to my hypotenuse squared. My hypotenuse is then the square root of 68, which is approximately 8.2. So we just counted the distance of the legs of that triangle. What if the coordinates were too far apart? Let's think of a formula that uses the coordinates that would be helpful. On this first one, we have a point at 1, 3, and we have a point at 7, 5. What is the expression for the length of the horizontal leg using the x-coordinates? That would be this leg right here. I went from 1 to 7. So what if I took and said 7 minus 1, or my second x-coordinate minus my first x-coordinate? Now what's the expression for the length of the vertical leg using the y-coordinates? I went from y equals 3 to y equals 5. So I said 5 minus 3 would give me 2, the length of that vertical leg. And that would be my second y-coordinate minus my first y-coordinate. Now, how did I find the segment that I was looking for, that hypotenuse? Well, I took my length of the leg here and squared it, and the length of the leg here and squared it. So I did x squared minus x1, that's the length of my bottom leg, and I added together y2 minus y1 squared, that would be the length of my vertical leg, and then I said that's my hypotenuse squared. What if I just want the hypotenuse with the distance? Well, I would take the square root of both of these, and that would leave me with just my hypotenuse. So the square root of my x-coordinates subtracted and my y-coordinates subtracted and then squared is equal to the distance. So the distance formula, if I want to find the distance between points A and B, I could write it as AB squared is the difference in my x value squared, or that length of the horizontal leg, plus the difference in my y-coordinates squared, or the length of that vertical leg. Or I could take, and if I just want the distance of AB, I'm going to take the square root of these legs squared added together. My first example is to find the distance between 916 and negative 624. So I'm going to assign this point as my first point, x1 and y1, and this one as my second point, x2 and y2. Remember that the distance formula is going to be the square root, because the distance is like my hypotenuse, and I'm going to take the values of my x-coordinates and subtract them. So negative 6 minus 9, and then I have to square them. And the difference in my y-coordinates, 24 minus 16, and square that. So negative 6 and negative 9 is going to be a negative 15. 15 squared is 225. And that is all inside the square root. 24 minus 16 is 8, and 8 squared is 64. So now I'm adding 64 plus 225, and I get the square root of 289. And when I take the square root of 289, I get 17. Whoops. Sorry, not the square root of 17, just 17 as my answer. So the distance between these 2 points is exactly 17 units. Example 2. Write an equation for the circle with a center of 2, 4 and a radius of 6. So to do that, let's draw a circle. Any point on the circle could be x, y. And the distance from there to the center, which we know is 2, 4, is exactly 6 units. So let's substitute that information into the distance formula and see if we can come up with the equation of this circle. So our distance formula is this distance d is going to be 6. And that is the square root of our x's subtracted. So we could just say x minus 2 squared, and then my y subtracted, or y minus 4 squared. So now that x and y could be any point on the circle. It could also be an xy coordinate down here. Again, it goes to the point 2, 4, and that distance is 6. So this is that information plugged into the distance formula. So how do we write the equation for a circle? Let's think about our previous example and the picture below to come up with an equation for any circle. So before, our radius was 6, and that was our distance that we used. So that's our answer. Let's use our r as our radius or our answer. And then we started with x minus 2 in the center, but now we're going to use h. So x minus h squared, and then y minus k is in the center, squared. Now I don't like this square root on the outside. What if I take that and just square both sides of the equation? So what if it's r squared is equal to x minus h squared plus y minus k squared? And that's exactly what the equation of a circle is. So we take our radius squared, or our distance squared, and we say that it's x minus h squared plus y minus k squared. Again, that's the difference in my x values, one being on the outside of the circle and one being the center, and the difference in my y values, the y being on the outside and k being in the center. And that xy could be any point on the circle. So find the center and radius of this circle. X plus 2 squared plus y minus 5 squared is equal to 36. Well, the 36 is my r squared, remember, because I took off of that square root from my original distance formula. So if r squared is equal to 36, then r must be 6. If I take the square root of both sides, r would be 6. Now my formula was x minus h squared plus y minus k squared is equal to r squared. If I kind of associate that up here, this is x minus h squared. So what are we subtracting if we have an x plus 2? We could rewrite it as x minus a negative 2. So our h is negative 2. This is y minus k, so our k is 5. So our center is h, k, and our radius is 6.